Okay, 14.2 is factoring trinomials where a is equal to 1. So this is us starting that we're no longer in the linear graphs. We are now looking at the quadratic graphs. These notes only go over one concept, and that is factoring trinomials when the leading coefficient is 1. Okay. What that means is if we have the equation x squared plus bx plus c, we are able to factor this by forming two binomials that have x plus a number and x plus another number. Okay, so the factors, we are finding the factors of c that add to b. Okay, and we'll see that in these examples here. So the first thing I like to do is I like to label my A, B, and C. Okay, so my A in this case is always going to be 1 because that's what the notes are over. B is 4, and C is that negative 45. Okay, so I need two numbers that multiply to C. So multiply to that negative 45. But add to 4. So here we're thinking of two factors that multiply to negative 45. What could be one example of two numbers that multiply to negative 45? 5. Good. 5 times 9. Okay. But one of them would have to be negative, right? So we could have a negative 5 times 9 or a 5 times negative 9. Are there any other factors you could think of? Okay. 3 times negative 15 would give us negative 45. Or the opposite, negative 3 times positive 15. Okay? But we're looking at all these factors that if we were to add the numbers together, we would get a positive 4. So out of all these factors, which ones would give us a positive 4 if we added the numbers? Good, this negative 5 and positive 9. Because if we add negative 5 plus 9, we get a positive 4. All these other ones, we would get numbers that were not a positive 4. So that means our answer here to factor is going to be x minus 5, that's that first number, and then x plus 9, that's that second number. Okay, and that's our answer. So the work that you would have to show here would to be just this table of showing your factors. Okay. And all of these on the notes are going to be this simple because our A is 1 in this case. We're only talking about the case when A is 1. Any questions on that one? Okay, so looking at number 2, our first step is to label our A, B, and C. So our A is always 1. In this case, B is what? That negative 5, just the number, okay? Not the variable, just the number. And C is that negative 14. So I need two numbers that multiply to negative 14 but add to negative 5. So first I go down and I just do my factors of negative 14. What would be those factors?
2 times negative 7.
2 times negative 7. We could also do the opposite of negative 2 times positive 7. Are there any other factors? I mean, we technically could do 1 times negative 14. That still gives us negative 14. Or negative 1 times positive 14. But out of all these factors, which one is going to give us a negative 5 when we add?
2 times -7.
Good. So this 2 plus negative 7 gives us the negative 5. So these are the factors we're using. No other factors would work. So that means my answer is going to be what?
X plus 2.
Good. X plus 2 because it's a positive 2. And then what? X minus 7 because it's a negative 7. That's our answer. Remember, our answer always is going to be X and then the number. X, then the number. If it's positive, we add a plus sign. If it's negative, we add a minus sign. So here we took a quadratic equation, a trinomial, and we factored it into 2 binomials. Okay, first I label my A, B, and C. In this case, A is always 1. What is my B? Good. What about my C? 50. So I need 2 numbers that multiply to what? 50, but add to negative 15. So I do this by just finding all of my factors of 50. So what are some factors of 50? Good. 5 times 10, or we could do negative 5 times negative 10. Any other factors? Good. We could do 2 and 25, or make both of them negative, negative 2 and negative 25. And so on and so forth. There's probably plenty of factors for 50. But do we already have our answer listed in one of those factors?
Yes.
In which 2 factors?
-5, -10.
Good, because if I add negative 5 and negative 10 together, I get negative 15, which means these are my 2 factors that are going to be in my answer. So if I was to write my answer, I would have what?
W minus 5 times W minus 10.
Good, both of my numbers were negative, so I know I was going to have a minus in each of them. And then notice our variable was W this time, so I would write W instead of X. If you make the mistake on an exam and write X, it's wrong, okay? Because this question is in terms of W, not X. Okay, go ahead and try number 4. I'm just going to be labeling my A, B, and C. Okay, so what did you guys get for your answer?
X minus 4 times X minus 12.
Good, so we are using the factors -4 and -12, but it's not x. What's our variable? Z,
Okay.
perfect.
We were just talking about that.
So if I add -4 and -12, I get -16. So that means I'm using -4 and -12 in my answer. So Z minus 4, Z minus 12 is our answer. So none of these other factors would work because if I add them together, I would not get a -16. Okay. Okay. There's actually sign rules for when factoring trinomials. Okay. So we have two cases here. We have case 1 where C is greater than 0, okay? So that means that last term at the end is a positive number. So if it's a positive number, that means there's only two possibilities for our answer. Both of the signs would have to be positive, or both the signs would have to be negative, right? Because a negative times a negative gives us a positive. So this C greater than 0, it tells us when the last term is positive. That's case 1. Case 2 is when C is less than 0. So that means our last term is now positive or negative? Negative. So that means if our C value is negative, the only signs that we could have inside of our answer would have to be opposite signs. So either a plus then a minus, or a minus then a plus. Because we want our C value to be negative, that means one of our answers will always be negative. Okay, and we saw that in the examples we did above when we were finding our factors. This is just more of a visual for those who need it. Okay. So sometimes when we're factoring trinomials, our A value is not always going to be 1, okay? So that means the first thing you would have to check is to see if it has a GCF. Okay, since these notes are over all the concepts of when A is equal to 1, we know that all of these problems coming up are going to have a GCF in order to make our A value 1. So looking at number 1, first of all, something is different about this problem. What do you notice? Correct, because what technically should come first? The p squared. So before we can label our A, B, and C and find the GCF, everything needs to be in the correct order. It should always be in ax squared plus bx plus c order. So always our squared variable first, then our single variable, then our constant. So in this case, this would be written as p squared minus 8p minus 48. Okay. Now that it's in the correct order, we are labeling our A, B, and C. And we are checking if A is 1. So in this case, is A 1?
Yes.
Correct. So since A is 1, that means we do not need to factor out a GCF. Okay. So in this case, we're just treating this just like a problem we did above. So we need two numbers that multiply to negative 48, but add to negative 8. So what would be those factors of negative 48 that would add to negative 8? Remember, we went through some of the factors of 48.
Negative
Good. Negative 12, positive 4. Okay. Why not negative 4, positive 12?
So that would be positive 8.
Good. That would give us a positive 8. So we're looking for the factors that when we add them, we're going to get the correct b value. So if I add these together, I get the negative 8. So that means these are part of my answers. So that means my answer here is what?
P minus
p minus 12
12.
and
P plus 4.
p plus 4, because negative 12 and positive 4 were the factors I found. So that's my answer.
You mentioned that on the test, that for something like this, the work that you want us to show is the table.
Correct.
When we are doing the table, like that right there, how you have it, would that be okay, or do you want us to list multiple factors?
No, this is okay. If you can't figure out what the factors are, list all those factors, you know, so you see it visually. But I'm not checking that you list all the factors of negative 48,
Okay.
just the ones that give us our answer. Okay, that's a good question. Okay, number 2, is this in the correct order? It's not, right? Because this has a t, then a t squared, then a t cubed. And remember, when we are dealing with quadratics, now that we're dealing with quadratics, we have to make sure that our variables are in order from greatest to least. So what term technically should be written first?
10t cubed.
Good. 10t cubed, then negative 30t squared, and then that negative 40t. Notice this does not look like ax squared plus bx plus c. So right away that tells me that there's possibly a GCF that I can take out. What would that GCF be? 10t, good. So if I take out a 10t, I am left with t squared minus what? 3t minus 4, okay? Once I factor out a GCF and I have my equation that looks like that ax squared plus bx plus c, I'm only going to be factoring what is inside the parentheses, okay? My GCF, however, is going to become a part of my answer. So once I have all the factors, I have to bring down that 10t to be a part of our answer. So here I have my A, my B, and my C. So I have my table, two numbers that multiply to negative 4 but add to negative 3. What would those numbers be? Good. So negative 4 times 1 gives us negative 4, but negative 4 plus 1 gives us negative 3. So negative 4 and 1 are our answers. So I have t minus 4 and t plus 1. But I have to bring down that GCF. So 10t will go in the front, and this whole thing is my answer. Again, if you forget to bring down your GCF, this would be wrong. Okay, if you just did the t minus 4 and t plus 1. If you had some steps there, then I give you partial credit, but just know that that GCF, if you have one, has to be attached to your answer. Any questions on 2? Okay, go ahead and try number 3. Just make sure it's in the correct order before you start. Okay. So the first thing you should have noticed that this is in the wrong order. So it should have been written as w squared minus 5w minus 6. Labeling this, I noticed that my a is 1, so that means there is not a GCF to factor out. So I just go straight to creating my table. So two numbers that multiply to negative 6 but add to negative 5. You should have got negative 6 times 1 as your factors because that multiplies the negative 6, but it adds to negative 5. Okay. So you guys should have got w minus 6, w plus 1 as your answer. Okay. And if you were going to ask if they were swapped, yeah, it doesn't matter. If you did w plus 1 and then w minus 6, that's still correct. Okay. Number 4, is that written in the correct order? No, what should come first?
2y to the 4th.
Correct, that y to the 4th needs to come first because that's the largest exponent. What exponent would come next?
30y cubed.
Correct, and then I have that 112y squared. Remember, my exponents had to go greatest to least. So right away, since I know this does not look like ax squared plus bx plus c, I know I'm going to have a what? Good, a GCF. What would be the GCF for this problem? 2y squared. Good, because I can take a y squared out of all three terms, and the largest number I can take out of all three is a 2. So if I divide that 2y squared out, I'm left with y squared plus 15y plus, what number? 6, 7, 8. I'm like, I can't think right now. What's 112 divided by 2? You said what? Louder, please. 56. Okay, so then from here, now I have everything labeled as my A, B, C. So I need two terms that multiply to 56 but add to 15. What would be those terms? Good, 8 and 7. And we would leave them both positive. Okay. We couldn't do a negative 8 and a negative 7 because that would give us a negative 15 instead of a positive 15. Okay. So 8 and 7. So I know I'm going to have y plus 8 and y plus 7. But is that going to be my entire answer? What do I need to bring to the front? Good, that 2y squared. I have to bring my GCF to the front before I circle my answer. Because if I have a GCF, that is part of my answer. Okay. Okay, number 5, we have negative a squared plus 6a minus 8. Is everything in the correct order? Yes, everything's in the correct order, so that's good. However, is my a value 1? No, what's my a value in this case? Negative 1. So since my a value is that negative 1, that means I'm going to have to take out a GCF to make it a positive 1. So what would be my GCF? Negative 1. So if I take out a negative 1 from this entire problem, what's going to happen to each of the signs? They're going to change. So now instead of negative a squared, I have positive a squared minus 6a plus 8. The only thing that changed since I took out a negative was that the signs went to the opposite sign. So positive to negative and negative to positive. Okay. So then looking at that equation that we found, we are now looking for two numbers that multiply to 8 but add to negative 6. What would be those two numbers? Good. Negative 2 times negative 4 gives us positive 8. But if we add them together, that gives us negative 6. So that means negative 2 and negative 4 are going to be a part of our answer. So I have a minus 2, a minus 4, and what am I missing from the outside? That negative 1, because that's my GCF. So that's my answer. So you could write that as a negative 1 on the outside, or technically we don't need that 1 there, and you could just write a negative sign. Okay? Either way, I'll accept. What do you notice different about number 6? Good, we have two variables here. We have a C and we have a D. In the cases like this, we choose one of those variables to be the variable, and the other one we're just going to treat like a constant. So what that means is what I'm going to do, since the C squared is already first in the front, I'm going to say that the C's are our variables, okay? Which means for now we are going to ignore the D and the D squared. So for now we're ignoring it. They're going to come back. We're just going to ignore it for now. So that means I have negative 2C squared minus 22C minus 60. Okay. Can I take a GCF out of that? Good, a negative 2. So my GCF is negative 2. Which means I'm left with C squared plus what? 11C plus what's negative 60 divided by negative 2? 30. Okay. I am going to use this equation to find my answer. So I need two numbers that multiply to 30 but add to 11. 5 and 6, perfect. So 5 times 6. Because if we add that, we get 11. So that means my answer is going to be C plus 5 and C plus 6. Okay. But remember I said those letter D's are going to come back into play, okay? What we do with them, since we had those extra variables, is we attach them to the back of our number. So instead of just 5, this is going to be 5D. Instead of 6, this is going to be 6D. Then we bring down our GCF, and this whole thing is our answer.
Now, is that just because you have the same, I guess, pattern for the variables? Like you have a single D with the single C, and then you have the D squared by itself as well?
Correct. So that was because we had a D and a D squared. That we were able to do it this way. If you usually just see the variable as is, so like if we just had a D in here, usually that means that can just come out when we take the GCF out and you won't have to deal with it. But in most cases, you will always have the like if you have an extra variable b, you'll also have b squared. And that just tells you to ignore it in the beginning and then add it to the end. Okay. And we could, again, check our work if we're not sure. In this case, we check our work by using the FOIL method. So we would multiply the c in, then multiply the 5d in, FOIL them together, and then you should get your original problem. So that's another way to check your work if you're not 100% sure. Okay. Number 7, is this in the correct order? Good, it's in the correct order. Is our a value 1? No, it's -1, so that tells us we're going to have a what? A GCF, which is going to be -1. And if we take out a -1, what does that change? I already told you the answer. It changes all the signs. So if I take out a -1, I'm left with x squared minus x minus 12. The only thing that changed was the signs. So now I need two numbers that multiply to what? -12. Always that c value, but add to -1, that b value. What would be our factors? So if we did -1 times 12, when we add that, that would give us 11. So that wouldn't work. -4 times 3, if we add that together, does give us -1. So we know our factors are going to be -4 and 3. So I have x minus 4, x plus 3, and the only thing I'm missing from our answer is the -1. Okay, number 8 is going to be similar to number 6. Go ahead and take a moment and try it on your own. Give you guys about 30 seconds to start it, and then we'll work on it together. So this is going to be one where you're going to have to ignore the b's for now. Okay, so I'm going to start going through number 8. You can continue working on it on your own. So on number 8, I noticed that I had two variables here. I had an a and a b. And also that second variable b had a b squared with it. That tells me right away that I'm ignoring those b's. So if I do that, I have the equation -3a squared plus 15a minus 12. My next step I'm looking at to see if it's in the correct order. Okay, it's all in the correct order. I have my a squared, then my a, then my constant. The next thing I'm looking for to see if my a value is 1. My a value in this case is not 1, so that tells me I have to take the GCF. So in this case, you should have took the GCF of -3. So if I take out a -3, I'm left with a squared minus 5a plus 4. Okay. So then I'm only looking at this equation when I'm finding my factors. So we should have found 2 factors that multiply to 4 but add to -5. And those factors would be -1 times -4. Because -1 times -4 gives me a +4, but if I add them, I get a -5. So those are going to be part of my answer. So I have a minus 1 and a minus 4. I left some gaps there because since I had those b's in the beginning, I'm going to have to bring those b's down and put them after the numbers. Once I do that step, I bring down my GCF because that's part of my answer, and then I have my entire answer. Okay. And for that a minus 1b, that could just be written as a minus b. We don't need that 1 in front of the variable. If you left it there, I'm not going to mark it wrong. Just keep in mind for the future proper ways to do things that's going to help you with other problems. Okay. Any questions about solving these trinomials? Factoring out a GCF from them, any of the above. The last part of this notes talks about prime polynomials. So sometimes when we try to factor a trinomial, there are no factors to be able to complete the problem, okay? For these notes, we're just going to talk about that if we can't factor it, we label them prime. In the future, you'll find out that if you cannot factor it, then you would use the quadratic formula, okay? But we're not talking about that just yet. We're just seeing how a trinomial could be unfactorable. So looking at number 1, we first notice that everything is in the correct order. We have x squared in the correct place and our x, okay? Then we check our a, b, and c. So a, b, and c. A is 1, so we're good to go ahead and proceed. So we need 2 numbers that multiply to 14 but add to -13. Okay? So as you would look at this problem, you would start to think, okay, what are these factors of 14 that could give me -13? And you would just start listing them. So I could have 1 times 14, -1 times -14, 2 times 7, -2 times -7. And then once I list all those, I'd be like, okay, well, those are all the factors of 14. There's no more factors of them. Well, let's see if any of them would add to -13. If I add the first one, I get 15. Add the second one, I get -15. Then I add 2 and 7, I get 9, and then -9. Since I went through every single factor of 14 and none of them gave me that -13, we say that this problem is prime. And all that means is that it is not factorable. Okay? So not that there's no solution, just that it's not factorable. okay? And in later notes, we're going to learn how to solve these if they are prime, if they're not factorable. Okay. However, on a test, if I'm asking you whether or not this is prime, this is what you would have to show me, that you tried all the factors and you added them all together and none of them matched up. And for these, I'm not going to give you a crazy number to factor. They're going to be pretty small, so they'll have like 4 to 6 factors. Okay, same with number 2. Okay, we first check if everything is in the correct order, which it is. Then we label our A, B, and C. We know that A is already 1, so we start creating our table. So we need 2 numbers that multiply to what number? 28, but add to -7. Okay? So my first step here would be to think in my head, okay, can I think at the top of my head any numbers that will give me that -7? If you can't, then you just start listing all the factors. So 1 times 28, -1 times -28, 2 times 14, -2 times -14, 4 times 7, -4 times -7. Okay. Then I think to myself, okay, I'm pretty sure those are all the factors of 28. Now I'm going to start adding them together to see if any of them give me the -7. So if I add the first one, I get 29, and then -29, 16, then -16, 11, and -11. So again, none of the answers that I chose from all the factors gave me a -7. Since that happened, this is a prime trinomial, which means it's not factorable. Okay, so if you have this on a test and you write no solution, that's wrong. Okay, it's not no solution, it's just not factorable, or you write prime. And then